Okay, we're going to talk about scientific notations today. So what is a scientific notation and why do we use it? Well, that is because we want to be able to express really large or really small numbers without putting all those like place values. So scientific notation is a way to make it easier to represent really large or really small numbers. Okay, and this is the format. You're gonna have a number times 10 to the power of another number. But this exponent tells you how many times move the decimal. So if you have a positive exponent, you're going to have a number that is larger than a 1. If you have a negative exponent, it makes numbers smaller than a 1. So like positive, larger, negative, smaller, that makes sense. Okay, let's go over some examples. Okay. I'm gonna ignore this middle column that says process. I'm just gonna go straight to the numbers. So we have a scientific notation here, and then we wanna convert into a standard form. First thing I'm gonna do is I'm gonna have to notice that exponent. I have a positive exponent. That means the number will be larger than 1. So it would make sense to move the decimal. I'm gonna start from the decimal point and move it 8 times to the right. So decimal place is 8 to the right. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to fill in the zeros into the bunny hops. And here I have my number. Make sure to count your decimals. And here we go. I have a whole number, so I have an 8 times 10 to the 4th power. So if I have just a whole number, I know that I'm going to have a decimal behind the last digit. So I can just put a decimal there. And since I have an exponent that's a positive 4, I could just move decimal 4 to the right. Put the decimal numbers. And then my decimal was here behind the 8. Now it's behind the 0. So my answer is 80,000. Now this time, notice that we have a negative exponent, so my number is going to be smaller than a 1. So it makes sense to move my decimal to the left. So I'm going to start from my decimal point, which is in between 4 and 2, but I need to move the decimal 1, 2, 3, 4, 5 times to the left. I'm going to place my new decimal here. I'm going to put in those zeros. Okay, here we go. You can also check your answers, okay, using the decimals calculator if the exponent is less than 7. If it's greater than 7 or equal to 7, it's going to show the numbers or answers in scientific notation form. But since my exponent is less than 7, I can just double check my answer. It looks like numbers are matching. Good. Okay. I'm just gonna give out the answer for the your turn part. So your answer should have been, here we go. You should have 9 zeros. And then for the next one, it's going to be 0.000732. And then 0.00000043 for the last one. And this is what I mean by calculator will just leave their answers as scientific notations, because it will if the exponent is equal to or greater than 7. Okay. Standard to scientific. So the exponent tells you how many places to move the decimal. You need to change your number to a value greater than 1 but less than 10. And then decide if you should have a positive or a negative exponent. Positive exponent if the standard form is greater than 1. Negative exponent if your standard number is less than 1. Okay, here we go. So we have 5,320. Obviously, this number is greater than 1, so we're going to have a positive exponent. Okay, so I'm going to just make write out my format here. Okay, so from here, that's where my decimal will be at originally. I need to move this decimal 1, 2, 3 places and stop right here between 5 and 3, so that way I have a number that is greater than 1 but less than 10. And I moved my decimal 3 times, so I'm gonna have a 3 as my exponent. Next one, 0.00075. This number is less than 1, so I know my exponent will be a negative number. Okay, let's move the decimals 1, 2, 3, 4 times to the right. And I have a 7.5, which is greater than 1 but less than 10. But since my original number was a less than 1, I should have a negative exponent. And also, you can check with the calculator. So I'm going to put 7.5 times 10 to the negative 4th power. And I have 0.00075. Cool. 420,000. 1, 2, 3, 4, 5. I had to move my decimal 5 times. So I have a number that is 4.2 now, which is greater than 1 but less than 10. I had to move my decimal 5 times. And I had a big number to begin with, so my exponent should be a positive number. I'm just going to give out the answers for your turn, because you should do it yourself. Like after you pause the video, and then you can check your answers with me. Hopefully you got the answers correctly. You can also check your answer with the calculator. Okay, word problems. A corporation earned a profit of $2.50 times 10 to the 4th power for the month. What was the corporation's total profit in standard form? So I'm just going to take the number. I noticed that my exponent is a positive 4, so I'm going to have to create a number that is greater than 1, so it makes sense to move my decimal to the right. 1, 2, 3, 4 times. Put a $sign back. So my answer should be 25,000. Okay, what is 0.0001 ounces in scientific notation? Okay, so number 2, a dragonfly has a weight of 0.0001 ounces. What is the weight in scientific notation? Okay, and to move the decimal 1, 2, 3, 4 times. So I have a number that is greater than 1. If it's equal to 1, that is okay. Times 10, I have to move my decimal 4 times. But look at my standard form. This number is less than 1, so my exponent should be negative. Okay, next one, number 3. What is wrong with the below value written in scientific notation? Write the value correctly in scientific notation and convert to standard. I'm looking at the number here they were multiplying with. Well, 57.3 is not between 1 and 10, because 57.3 is greater than 10. So we have to move the decimal one more spot so that we're creating 5 and 7/300. Now we have a number that is greater than 1 but less than 10. So I had an exponent of or power of 9. So since I moved one decimal place over, I need to change this to a 10. And that's it.